Origin story. The Cold War crucible. The genesis of the Eurofighter Typhoon lies in the mid-1970s, driven by the realization that Europe's leading air forces, the UK's Royal Air Force, Germany's Luftwaffe, and later the air forces of Italy and Spain, needed a new generation of agile air superiority fighters. The existing fleets, particularly the aging Phantoms and the single-role Jaguars, were facing an increasingly sophisticated threat from new Soviet aircraft like the MiG-29 and Su-27. The requirement, formalized under projects like the UK's Air Staff, Target AST 403, and the subsequent European Fighter Aircraft EFA program, was clear. A highly maneuverable fighter, capable of defeating any Soviet aircraft after 1995. The multinational collaboration, a complex undertaking managed by Eurofighter GmbH, was a testament to pan-European ambition, but was also fraught with political and industrial friction. France eventually left the consortium to pursue its own Dassault Rafale, leaving the four core nations to develop a machine that prioritized pure air-to-air supremacy. The eventual aircraft, drawing heavily on the British Aerospace EAP experimental aircraft program, Demonstrator, was designed from the outset to be the world's most capable dogfighter and long-range interceptor, a true Cold War warrior, built on the eve of its conclusion. Design and engineering. The canard-delta. The Typhoon's stunning silhouette is defined by its close-coupled canard-delta wing configuration. This design choice, incorporating the forward canard wings and the main delta wings, provides exceptional supermaneuverability across the entire flight envelope, particularly at high angles of attack and supersonic speeds. Crucially, the airframe is aerodynamically unstable by design. This inherent instability, which would be impossible for a pilot to control manually, is tamed by a high-speed quadruplex digital fly-by-wire FBW system. The FBW constantly makes thousands of minute adjustments, granting the pilot what is often described as carefree handling, allowing maximum performance without fear of overstressing the airframe to achieve superior performance and agility. The airframe utilizes an extraordinary amount of lightweight, high-strength materials. Over 70% of its surface is made of carbon fiber composites and glass-reinforced plastic, significantly reducing weight and boosting performance. While not a dedicated stealth fighter in the vein of the F-22, the Typhoon incorporates significant low features, including the shaping of its leading edges, the use of radar-absorbent materials, ram coatings on key surfaces, and serpentine air intakes that partially mask the radar reflections from the engine fan blades. At the core of its operational capability is the sensor suite. The initial models relied on the formidable CAPTOR-E mechanically scanned radar. But the ultimate capability is realized with the current CAPTOR-E active electronically scanned array. This powerful system offers unprecedented electronic protection and the ability to interleave multiple modes simultaneously. Complementing the radar is the PIRATE passive infrared airborne track equipment sensor, an advanced infrared search and track IRST system that allows the jet to detect and track targets without emitting a revealing radar signature, a critical advantage in a highly contested airspace. Engines and power, thrust and supercruise. Propelling the Typhoon are two EJ200 afterburning turbofan engines, a collaborative European effort. Each engine delivers a thrust of approximately 13,508 BF Rokas UKN dry and a monumental 20,250 lbf 90 kilonewtons, with afterburner engaged, totaling over 40,000 pounds of thrust. This power, coupled with the lightweight airframe, results in a thrust-weight ratio exceeding 1:1 in air-to-air configuration, giving it blistering acceleration and climb performance. The most celebrated feature of this propulsion system is its supercruise capability, ability to sustain supersonic flight at speeds of up to Mach 1.5 without resorting to the fuel gazillion afterburner. This dramatically extends its operational radius and endurance at high speed. The Typhoon has an official maximum speed exceeding Mach 2.0. Weapons and systems. The swing roll arsenal. The Typhoon is a true multi-rolly or swing-a-roll aircraft, capable of engaging air and ground threats simultaneously for air-to-air dominance. Its primary weapons are the AIM-120 AMRAAM and the Statoviat MBDA Meteor Beyond Visual Range Air-to-Air Missile BVR, a weapon with a unique ramjet motor providing sustained high speed and a massive no-escape zone. for close combat. It carries IRST or ASROM heat-seeking missiles, slaved to the pilot's helmet-mounted symbology system, HMSS-4 off-bore sight shots. Its transition to ground attack has been aggressive and successful. The jet is cleared to carry a wide array of precision-guided munitions, including pathway for laser-guided bombs, the Storm Shadow long-range cruise missile, and the Brimstone anti-armor missile. Targets are designated using an external targeting pod, such as the Lightning. For the final, desperate close-in fight, it retains a formidable internal 27mm Mauser BK-27 cannon. The entire system is protected by the Praetorian DA's Defensive Aids subsystem, an advanced electronic countermeasures ECM suite that provides radar warning, automated countermeasures, and electronic attack capabilities. Combat and operational history. Despite a long gestation period, the Typhoon has proven its mettle in operation. It has formed the bedrock of quick reaction alert QRA duty for all 4 partner nations, scrambling daily to police sovereign airspace. Its first major combat deployment came in 2011 during Operation Ellamy, Libya, where it demonstrated its multi-role capability, conducting both air defense and precision ground attack missions. It has since flown countless combat hours in Operation Shader against Daesh targets in Iraq and Syria, consistently performing air interdiction, reconnaissance, and close air support. Furthermore, it plays a vital role in NATO's air policing missions, securing the eastern flank of the alliance from the Baltic to the Black Sea. Its performance in large-scale NATO exercises like Red Flag has repeatedly highlighted its kinematic and sensor superiority against rival platforms. Tactics and doctrine. Dominating the battlespace, Typhoon pilots employ a doctrine built on energy management and information superiority. Its immense thrust allows pilots to retain energy during high-G maneuvers, a crucial advantage in a turning fight. However, its primary mode of operation is to leverage its AESA radar and network connectivity, especially through the multifunction information distribution system MID. Data Link 2. Create a unified, clear picture of the battlespace. The tactic is to execute beyond visual range BVR engagements using the Meteor missile, engaging targets at long range while maintaining a high supercruise speed to maximize missile energy. The pilot acts less as a lone fighter and more as a human-in-the-loop decision-maker, managing the fused sensor data from the aircraft's own systems and the broader network. In a close-range fight, the canard-delta's instant turn rate and the HMS-slaved missiles make the aircraft a terrifying opponent, often able to achieve a kill with a mere glance at the enemy. Comparison. Rivals and contemporaries. The Typhoon is frequently compared to its closest European contemporary, the French Dassault Rafale. Both are highly capable for 5th-generation jets with canard-delta configurations. The Typhoon is often cited as having superior kinematics, a higher top speed, better acceleration, and superior sustained supersonic performance due to its more powerful engines. The Rafale, however, is praised for its smaller size, more comprehensive omniroll capability from its inception, and its unique navalized variant. When measured against the American F-15E Strike Eagle, the Typhoon is significantly more agile and possesses superior short-range kinematics, while the latest F-15 variants boast massive payload capacity and a higher absolute thrust. The Typhoon's advanced AESA radar and sophisticated Praetorian DASS give it a significant edge in electronic protection and sensor fusion, placing it firmly ahead in the pure air-to-air role. Modern relevance. The bridge to the future. The Eurofighter Typhoon is the backbone of the air forces of the core nations and has found substantial export success with users like Saudi Arabia, Austria, Kuwait, and Qatar. Its service life is planned to extend well into the 2060s, a testament to its continuous upgrade path. The long-term Evolution LTE program focuses on integrating new weapons and most critically deploying the advanced ECRS, European Common Radar System, Mk2 AESA radar, which will provide sophisticated electronic attack, EA and suppression, destruction of enemy air defenses, dead capabilities. This modernization ensures the Typhoon acts as the essential technological bridge to the future. Networked Future Combat Air System FC, where it is envisioned to team and command unmanned loyal wingman drones. Emotional ending. Reflection. The Eurofighter Typhoon is more than an airplane. It is a powerful symbol of European industrial and military collaboration. It represents the collective will to maintain air sovereignty and a defiant commitment to remain at the forefront of combat aviation. Its sleek, predatory form, slicing effortlessly through the sound barrier, embodies speed, agility, and precision. It is the last great interceptor of the Cold War lineage, seamlessly transitioning into the sophisticated, networked multi-domain warrior required for the modern battlefield. The Typhoon does not merely fly. It dominates the skies, ensuring the freedom of movement for those beneath its protective high-speed shadow, a thunderous echo of unparalleled air power.